and I'll try to understand basically, we will try to understand basically the superposition of biological systems. So this will be our target, and we will be trying to understand the superposition that's already going on in the biological systems, the systems that possess biological life. And we would like to do it. We will not try to make it more stiff, and we would like to make it simple so that we understand that how we can correlate the quantum mechanics with the biological systems. So what we are going to talk about is the superposition in the biological, I call it biological decision pathways. So this is something that we would like to talk about. We would like to take on a ride, and we would like to take on some of the examples where we can actually incorporate this mathematical concept in quantum mechanics that's actually happening in our biological systems. And this phenomenon, we call it as quantum mechanical superposition. So if I start with like this, that your body is, it's right now it's making decisions, and it's making decisions without asking you. It's not asking you to build those decisions. Your body is making most of the decisions without asking you. And your heart chooses a rhythm. My heart chooses a rhythm. Your cells choose reactions. And your brain, our brain, it chooses the pathways. It chooses the selections. And here we'll be talking about this unsettling truth. We will try to understand this unsettling truth. And to go with this, if I say that before any biological decision is made, there are multiple possibilities before that decision, because there are multiple possibilities that coexist before you take a decision. This is not metaphorically, I am not talking about it in metaphorical sense, I'm talking it about statistical sense, I'm talking it from mathematical point of view. I'm not doing any kind of poetry here. It's all, I'm trying to understand it in the framework of science. And I'm all trying to understand it physically. And this is what we are going to talk about. This is the point. The point is the superposition. And what we have is we have the quiet states of many possibilities at once. And inside the biologically living systems, what superposition is basically, and what superposition really means, and how we can try to understand it, how we can try to learn it to a level where at least we can feel about it. So in quantum mechanics, a system does not occupy one state. This is perhaps most weird, but at the same time, the most beautiful mathematical argument of quantum mechanics. It exists in many states. It exists in many states simultaneously. As I said, it exists in many states simultaneously, and we can write down this simultaneity in mathematical version. It's not a kind of confusion. It's not metaphorical. It's not philosophical. It has a mathematical structure. And this structure and connected this thing to the biological systems. And biological systems astonishingly uses it. And as always, a story, the undecided crossroad, a story that can take us to this learning. I'm telling you that you imagine standing at a crossroad, and the left of you leads to the hole, and the right of you, it leads to somewhere unknown. You don't know what's the destination. What does this path leads us to? Now, before you move, what do you do? You are not on the either path. Neither are you on the left of your path, nor you are on to the right of your path. You are actually on both the paths. You are on both the tracks, potentially. What am I trying to tell here is, what I'm trying to express here is, a path is leading to your home, and another path does not lead to anywhere. So there is that point of hesitation, there is that moment of hesitation, there is that point of superposition. This point is a perfect analogy for the superposition. You are biologically in a superposition of the two paths. And the same story is happening at the molecular level. It's happening at atomic level. And automatically it's happening at biological systems. So biological systems, they pause. They pause when there are overlapping possibilities. And before setting into one outcome, before coming up one decision making, before coming up with one result, the decision is not instant. It's a result. It's something that has been resolved. And can I connect this thing now? Can I think in terms of superposition in folding of proteins? The very character of proteins to fold. Proteins, they do not fold step by step like instructions. They don't use logic gates. They don't use zeros and ones. They explore many shapes at once. And each shape corresponds, each shape can be linked. It can be linked to the quantum allowed state. It's not continuous. there is discreteness. Now, only when stability is reached, the folding of the protein, when stability is reached, one action dominates, one form dominates, one shape dominates. Let me take you to another imaginal story here. A paper. You imagine that you have a sheet of paper, and you are dropping this sheet of paper. Now, before this sheet of paper lands, what it does, it will twist. It twists through countless shapes. You have a paper, you allow it to fall under gravity, there is air, it does twist in many shapes. And only one becomes the final shape. Let's try to understand it. Let's try to learn. Can I connect it with the protein folding? Yeah, of course. Protein folding is not a trial and error kind of thing that's going on. Because our present world is running on error and trial things. It's happening simultaneously. It's simultaneously exploring. It's simultaneously exploring infinite number of states. And superposition allows proteins to sample many configurations. So there is sampling of many configurations. Now, without physically testing each one, because when you'll test, you'll have just one. But before you are making a test, there are a large number of shapes. And life saves time by being quantum. Let's take another everyday example. A smell and a taste. These are two important sensing agents that have you ever noticed that how fast you recognize a smell? It seems instantaneous. Even you have not thought about it. And before you can even say a word, before you make it lingual, before you make a phrase of it, it is there. This speed is not classical. This fastness of smelling is not classical. What is it? Molecules in your nose. What they do, they interact. They interact with the receptors. They interact with the receptors through the overlapping. And the overlapping has a large number of vibrational states. Let's go to another example. There's a lock, and this lock listens. You imagine a lock that does not wait for keys. You don't need a key to open it. But it listens. It listens to its vibrations. You have a lock, it listens to your talk. What does it mean? There's something what we call as olfaction involves. There is an olfaction that involves this quantum superposition. A superposition of vibrational modes. Your brain, our brain, what it does basically, it collapses the possibilities. And right now in my brain, there are billions of possibilities, but what I'm coming up with is the collapse into a single perception. In the similar way, smell is a decision already made from many overlapping quantum states. You have not even become lingual for the smell, but it's already there. Superposition. You have superposition in the neural paths, in the neural network. The neural networks that we have in our brains. Our brains never follow one path initially. Our brain follows infinite number of paths. The multiple neural paths, they become active, they actively participate, they become active together, and only later does one dominate. Let's try to understand it. Another important story. A crowd of voices. You have a room, assuming that there is a room. Imagine that you have a room. This room is full of people. They are all speaking at once. There's a cohesion. Slowly, one voice becomes clear. They're all speaking one voice, and one voice becomes clear. How can I connect it? Maybe this is an example. This is an example about the neural decisions. The neural decisions, they are resembling, making resemblance. They resemble this quantum resolution. So, multiple pathways coexist. And the feedback suppresses. Some amplify and others do not. And you have the conscious choice. A conscious choice emerges. It emerges from a field. It emerges from a long range of possibilities. Can I take it down to any other day-to-day problem, the day-to-day example? Reaction time. We always talk about, we use reaction time when driving a car. You pull your hand away from heat, the reaction time. Before you think, you're not thinking. Before you think, you pull your hand. You pull it because you feel hot. That decision is not planned. Can you imagine that this decision is planned? No, it's resolved. It's resolved instantaneously. It's a result of the collapse of the superposition. I'm taking an example of the certain flinch. What you do is you see something falling. When something falls, your hands move. Your hands move instantaneously. Before your mind speaks, before you have words, what you do is you take your hands towards that. Now, what does it mean? How I can explain this? And we have very, very, very canonical point of explanations like reflexes. Reflexes arise from a pre-existing superposed pathways. The fastest path wins. There are many paths, but the one that amplifies to the maximum leads us. So biology does not deliberate. It basically collapses these possibilities. And why? This is why I'm telling you that why superposition matters. It has to do everything with the biological life. And superposition is quantum mechanical in nature. It's not the classical superposition. If biology waited for a single option, life would slow down. It would slow down to the lowest. But what superposition does? Superposition allows the speed. The superposition allows flexibility. The superposition, the quantum mechanical superposition, it allows resilience. And life prepares many futures. And selects one when required. A kind of collapse. Now coming to that invisible action. The invisible action returns here. No organism controls superposition. There is no control on that superposition. Cells do not choose to be quantum. It's not their choice. What they do basically is they obey it. The invisible action continues. And it frames. And it frames the unseen. It frames the ungoverned. It frames the unavoidable. Now let's go back to the coin. The coin, which has the two possibilities, a tossing coin. Now if you imagine that you have a coin and you flip it, the flipping of a coin, we usually talk about the outcome. While this coin is spinning in the air, it's neither heads nor tails. It's both. Only when this coin lands, when it lands, you have a certainty here. And the certainty appears. And maybe the question is, does the certainty appear here? Now to understand this, now to realize this, the biological decisions behave in the same way. Certainty is not fundamental property. Certainty is not something fundamental. It is the end of a process. The end of that unknown, the end of those infinite possibilities that are going on. It's not even the beginning. The certainty is only the end of that spinning coin. Otherwise, there is no certainty till then. And this is why the classical biology misses this, because the classical biology is based on those gates. It's based on those zeros and ones. It's based on the classical laws of physics. And classical biology studies those outcomes. But quantum biology is a framework that looks for the possibilities. In classical biology, you have certainty. You think classically. You have a classical thinking. And what happens in classical thinking? What happened? This is classical thinking. Now, if I talk about the quantum thinking, if I ask, what is quantum thinking? It's like, what could have happened? So, life lives in the second question. It does not live in the first question. It does not live in the classical biological argument. It lives in the quantum mechanical argument. What could have been possible? Now I want to close this argument. Every biological decision that we have, it forms a heartbeat. Okay, from heartbeat maybe to a thought or an overall survival. Now this all begins as a superposition. Life does not, I'll again use the word, life does not walk a single road. It stands at many crossroads at once.